Consider the curve is equation e to the power negative 2x squared for x less than 0. Find the coordinates of the point of inflection and justify that it's the point of inflection. To be a point of inflection, the necessary condition is the second derivative should be equal to 0. So we need to find the second derivative and equate it to 0. To find the second derivative, we need to find the first derivative firstly. So we need to find the derivative of this function, and we can consider it as e to the power of x, but more complicated argument, and apply a chain rule. So it becomes e to the power of x derivative, it's the same, so we keep the argument, so derivative will be the same, but according to the chain rule multiplied by the argument derivative. It's just a chain rule, and hence it becomes negative for x e to the power of negative 2x squared. Hence the second derivative becomes the derivative of this function, and here we can see it's a product, so we apply product rule, and it says that it's negative for x derivative e to the power of negative 2x squared plus negative for x e to the power of negative 2x squared derivative, and it is equal to negative 4 e to the power of negative 2x squared minus 4x, and its derivative is this one, so plus 4x e to the power of negative 2x squared, and it should be equal to 0 if we want to find the point of inflection. E to negative 2x squared cannot be equal to 0 at all. We can write this, e to negative 2x cannot be equal to 0, hence negative 4 plus 4 times 4 x squared is 0. We can divide each term by 4, so it becomes negative 1 plus 4x squared is 0. So x squared is 1 over 4. X is plus or minus root of 1 over 4, but x is less than 0, so it's negative a half. Let's find the y coordinate. So y is e to the power of negative 2 x squared, so it's 1 over 4, so it's e to the power of negative a half, which is 1 over root e. So point is negative a half 1 over root e, and we need show, or we need justify that it's a point of inflection. How can we justify that it's a point of inflection? And actually, what is the point of inflection? Point of inflection is a point where curve changes its concavity. And we know that function is concave up where the second derivative is greater than 0, or the first derivative is increasing function, and function is concave down where the second derivative is less than 0. So to show that function changes its concavity at x is negative a half, we can consider a point a bit to the left, for example negative 1, and to the right, for example negative 1 over 4, and the second derivative at negative 1 is, where is the second derivative? It's this expression, and we need actually sign only, and when it's negative 1 we can see that it will be 1, so 16 minus 4, so and it's always positive, so it's positive. You can write this expression, rewrite this expression substituting negative 1 for x, and the second derivative at negative 1 over 4, it will be 1 here, negative 4 plus 1, it will be negative. Hence, we can see that, and you should write this, the second derivative changes sign at x is negative a half, hence a function changes concavity at x is negative a half, therefore it's a point of inflection. Or another way is, and it's acceptable, to show that the third derivative at negative a half is not a zero. And it's enough to justify that it's a point of inflection. So we need just find the third derivative. It's derivative of the second of this expression, and for some problems this way may be more useful, more easier. And that's all for this question.